I've come up with a plan for a real working lightsaber. Its blade is made of superheated plasma. It'll slice through anything, but I have one big problem. I need a staggering amount of power, 15 megawatts, enough to light up a small town.
A lightsaber is only as good as its power source.
In the handle is going to be a power source and controls on the outside.
It needs a hell of a cell phone charger.
Yeah, or
There's
charger,
no way
or
around
like I
it.
said, one big battery.
A powerful battery, certainly. One that can heat plasma to 12,000 degrees. But it can't be big. There simply isn't the space in the handle. It's a big problem, but I think I might have a solution on a tiny atomic scale. Just how tiny is mind-blowing. Imagine you scale up one hair on my head to the size of the Empire State Building. Then an atom would still only be the size of a sheet of paper lying on the sidewalk. Well, that's how big the building blocks of my power source will be. Welcome to the nano world. This is a carbon nanotube. It's made from a string of individual carbon atoms. They are incredibly strong, incredibly small, and they could hold the key to building my lightsaber. Brian Wardle researches nanotubes at MIT.
On this wafer, we have placed catalyst seeds, and the nanotubes grow from the seeds.
Brian can show me how to build carbon nanotubes, but he can't talk about his main research, the military applications of nanotechnology. That's top secret. But we did discuss sci-fi weapons and how the symmetrical way carbon atoms stick together could be very useful for powering my lightsaber.
Let's see what we have.
They are extremely tiny. A single carbon nanotube is only 50 atoms across. That's 20,000 times smaller than the width of a single human hair. You're looking at a close-up of a single nanotube. The bumps you can see are the individual atoms. It's part of a forest of millions of carbon nanotubes. But how does this help power my lightsaber? Well, carbon nanotubes do something that carbon itself doesn't usually do. They conduct electricity. The unique symmetrical structure of the nanotube means that it has metallic properties. Incredibly, it can conduct 1,000 times more electricity than copper. So you can make a very basic battery out of them, one that simply holds a charge between two plates.
Now imagine that rather than two plates, we're going to have trillions.
So the battery stores tremendous amounts of energy on each plate, but if you have trillions of these plates on a molecular scale, you're talking about fantastic amounts of charge.
Yes, so that's the idea. Very high surface areas that can be created with nanostructured materials.
I could easily fit trillions of nanobatteries into the handle of my lightsaber. They're only an atom thick. Manufacturing this many might sound like a tall order, but it turns out it's easy to grow nanotubes.
You can imagine the seed particle being the size of a soccer ball. And we'd have a soccer pitch or a soccer field full of these soccer balls. The nanotubes would be growing from the soccer balls very, very fast, in excess of 100 kilometers an hour. And they would grow into low Earth orbit in a matter of minutes.
Scientists still don't understand why nanotubes grow the way they do. When they have uncovered the mystery of their growth, they may well be able to create the kind of batteries that I will need for my lightsaber. These batteries might be able to deliver the enormous amounts of energy necessary to generate and contain a plasma. Now, space wouldn't be a problem. We can store literally miles of carbon nanotubes and molecular batteries inside the hilt of a lightsaber. But is my design really a lightsaber? I've traveled a long way from sci-fi. I'm starting to wonder if my blueprint will convince the fans. Get more sci-fi science online.